Hi, I'm an old guy and I do maths. Today we're going to differentiate this, and it may well terrify people. There's no need for it to do so. There are simple rules, and if you follow them, it's a simple job that can be, it can be done in a jiffy. It can be done really, really quickly and simply. Okay, so we've got two expressions here, and we deal with them in the way that you deal with any problem where you've got more than one expression. You do one thing at a time. Now let's have a look at our general rule, which if you've watched previous videos you will have seen. But the function of x is equal to e to the kx. Now the k is the constant. Okay, now it's usually a number, but it could in theory be a letter. Anyway, the differential of this becomes k times e to the kx. And how this comes about is by means of the chain rule. So basically what we do is we break this problem up into parts. We name this u, and we find the differential of u, and we find the differential of e to the u. And so let's get to it. So one of the first things I'm going to do is I'm going to rewrite this in a form in which it's easier to work with, and I have done this here. So we have function of x is equal to e to the negative 5x plus e to the 2x plus 1. Okay, now applying the rules, this becomes very, very simple. So just give me a moment to write something in here, and this is what we get. We get negative 5, the differential of this, times e to the u, we've named this u, and so it is negative 5e to the negative 5x. Over here we get 2, which is the differential of this expression here. That's one way of looking at it, and I'll come back to how I deal with that. So it's 2e to the 2x plus 1. Now that's an adequate answer, but we were asked this question in a particular form, and so I'm going to give the answer in that form. I'm going to rewrite it in the way in which the question was asked. If you look up the page, you'll see that the question was asked in this form. So I'm putting it back in this form, no big deal. Now, I want to explain this. So how we come to this is by means of splitting up this expression. So for those of you who are interested, have a look at this. So this is e to the 2x times e to the 1. Okay, now that's u and that's u, and we will differentiate both of these. So if we do that, what we get is we get 2e to the 2x times 1e, that's k, we bring k down here, that's the constant, e to the 1. Now, index rules say that because the bases are the same, we can simply add this, so we get 2e to the 2x plus 1, for those who are interested. If you're not particularly interested, the simple rule is that you will differentiate this, you'll put it in front of e, and then it's times e to this, which gives you this. Okay, thanks for watching. I hope you found this interesting. This is a really good lead into how we differentiate logarithms, which you will notice is further along in the playlist. And I will see you on the next video. Thanks for watching. Bye.